Hi, so this is the second part on proportion then, so 14.5b, inverse proportion. Today's objectives, we're going to understand what inverse proportion means and to be able to create and solve inverse proportion problems using algebra. So again, let's check our prior knowledge before we start. So we should be able to simplify ratio into the form 1 to n and n to 1. I've given a couple of examples there. You also really do need to be able to rearrange a formula for a specific letter. So we're going to do quite a lot of that today. So for example, if r equals 5s and we want to rearrange it to make s the subject, we would divide both sides by 5, giving us s equals r divided by 5. And we should understand what is meant by the constant of proportionality. So if you've done the first part of this lesson, you should understand what we mean by constant of proportionality. Things you'll need then, you need to make sure you've got your maths book or some paper, a pen or a pencil, and a scientific calculator. Okay, so inverse proportion then. Inverse proportion is as two quantities are inversely proportional if one increases and the other decreases at the same rate. So remember, with direct proportion, both were getting bigger or both were getting smaller at the same rate. With inverse proportion, one's getting bigger and the other is getting smaller at the same rate. So they're going in opposite directions. So for example, the speed a car travels is inversely proportional to the time it takes to cover the same distance. So if a car doubles its speed, it will take half the time to cover the same distance. If it trebles its speed, it will take a third of the time to cover the same distance. And if it halves its speed, it will take double the time to cover the same distance. Okay, so the sorts of problems we might be looking at then. So at a sorting office, it takes one person 1 hour to put 150 letters into envelopes. How long would it take 5 people working at the same rate to put 150 letters into envelopes? So that's quite important. We're making an assumption. Sometimes we're asked what assumptions we've made. We're assuming that all of the people are working at the same rate. We haven't got some people who are working really fast and some people who are going really slowly. Okay, so that's important. So as we've got more people, it should take us less time to put them into envelopes. Okay, so if one person takes 1 hour, so 5 people should take 1/5 of an hour. So they're splitting up that hour between the 5 of them. So 1/5 of 60 minutes means it should take them 12 minutes. Okay, so the more people we have, the less time it's going to take us to put those 150 letters into envelopes. So the number of people and the time taken are said to be inversely proportional. As one got bigger, the number of people got bigger, the amount of time got smaller, but it does it at the same rate. Okay, so let's have a look then at how we're going to use that to help us to write a formula so that we can solve problems. So the time t that it takes meals to be served at a busy restaurant is inversely proportional to the number of waiters working at the time. Okay, so it takes 20 minutes to be served when 12 waiters are working. Find an equation connecting T and W. So obviously the more waiters we have, the less time it should take us to get served. So now we're going to write again our statement of proportionality. So we'll start with our statement. So our statement this time says that T is proportional to 1 over W. Now before we've multiplied by a value and this time we're dividing. So if we turn that into our equation here, you will see that instead of multiplying by k for direct proportion, we're actually dividing. So here we've got, okay, T is equal to k divided by W, because as one gets bigger, the other needs to get smaller. To get smaller, we're using division to get smaller. Okay, so once we have our formula, we're now going to put in our values. So we're substituting our two values we were told 20 minutes and 12 waiters. So T is 20 and W is now 12. Now again, remember we want to find the value of k, so I've got to get k on its own. So we need to get rid of the divided by 12. To get rid of that, we do its opposite. So we're going to multiply both sides by 12. If I multiply both sides by 12, then that gives me k as 240. Once we find the value of k, we substitute it back in to our original equation. So we're going to swap out k, and we end up with t is equal to 240 divided by w. Once we have this formula, we can use it to help us with our problem solving. So remember, these are the same steps that we used for direct proportion. The main difference is that instead of having k multiplied by a value, we've got k divided by another value. Okay. All right then, so your turn then. So again, pause the video, have a go. Remember, start off with your statement of proportionality. So where it says inverse proportion, it means we're going to have a division instead of a multiplication. So start with your statement and then your equation, substitute in your values, find the value of k and write it back into your formula. All right, let's talk through these then. So we were told y is inversely proportional to x. So our statement of proportionality, y is proportional to 1 over x. That's our inverse. Change that into an equation. So we're going to say y is equal to k over x. Substitute in our values for x and y. So remember, the y is 6 and the x is 10. Now we want to find k, so we're going to multiply both sides by 10. So k is 60, and once we know that k is 60, we can put it back in to our original formula, so y equals 60 over x. The second one, s is inversely proportional to t. So remember, we start with the first letter, so we're going to start with s, proportional to 1 over t, that's showing our inverse. Change that to s equals k over t, substituting the values of s and t. We're going to multiply both sides by 0.4, and that will give us the value of k, which is 8, and we substitute it back into our formula. So s equals 8 over t. Finally then, in context, so an electrical current, the current I is inversely proportional to the resistance R. Write an equation when the resistance in the circuit is 12 ohms and the current is 8 amperes. So we've got I is inversely proportional to R, so I is proportional to 1 over R. We change that to an equation. I is equal to K over R. Substituting our values for I and R. So the resistance R is 12 and I is 8. We're going to multiply both sides by 12 to find K. K is 96, and we put that back into our original equation. I is equal to 96 over R. So notice with all of these where we've got inverse proportion, they are all divisions. All right. Okay, so going back then to our weighter problem, we've got our formula that we found earlier. So up here then we've got our t was equal to 240 divided by w. Remember, our fraction line over means division, so that's divided by w. Okay, we're going to use that to help us to solve some problems then. So our first problem then, how long would you have to wait to be served if there were 10 waiters working? So we know the number of waiters is 10, so we start off with our formula. We're going to swap w for 10, so 240 divided by 10. We would need to wait 24 minutes if there were 10 waiters. How many waiters are needed to ensure people get served within 15 minutes? So this time we know the time. So again, starting with our formula, we're going to swap t for 15. Now we need to rearrange it. Now remember, when we're rearranging these, the division is divided by w, so I need to get rid of this first. So we're going to multiply both sides by w. So that's W times 15 equals 240. Now we want W on its own, so we have to divide both sides by 15. So we've had to do 2 steps there with that one. Remember, you can't move the top of a fraction, okay? So you have to do it in 2 steps. So the number of waiters is 240 divided by 15. So we would need 16 waiters to ensure the guests don't wait more than 15 minutes. Make sure you're happy with those before you move on. So in general, our questions will ask us to find a formula and then use it to solve a problem. So we're going to have another look now at some exam questions of different types. So again, with our exam questions, some of them are broken up into steps for us. We've got some scaffolding involved and some of them won't be. So you can either pause the video and have a go at the question yourself first, or you can work along with me as we go. All right then. So our first question then is the frequency in F kilohertz. Okay, a radio wave is inversely proportional to its wavelength, W meters. When W is 200, F is 1500. Express F in terms of W. So first of all, it wants us then to write our equation. So we were told that F, okay, is proportional, so inversely proportional, so 1 over the wavelength, which was called W there. Okay, so we're going to turn that into a formula. So we get F is equal to K over W. We're going to substitute in our values. So F was 1500, and that's equal to K over 200. So we need to rearrange the equation. So we're going to multiply both sides by 200. So 1500 times 200, which gives us K. Now that means that K is equal to 300,000. There's our value of K, and we're going to substitute that back into our formula. So F is equal, we're swapping out the K for our 300,000 over W. So we've now expressed F in terms of W. So that's our first part. All right then, the second part of the question then, it says the wavelength of the radio wave is 1250 meters, calculate its frequency. So we're going to use our formula. So frequency then, we know is 300,000 divided by W. Now W this time was 1250. So our frequency is going to be 240 kilohertz. Okay, make sure you're happy with that one before we move on. So this one had some scaffolding, it broke it down into 2 steps for us. Okay, our second question then. So we can see then the light intensity E at a surface is inversely proportional to the square of the distance r of the surface from the light source. We've been told E is 4 when r is 50, and again it's broken down in steps. We're asked to express E in terms of r. So we start off with our statement. So our statement said then that E is proportional to 1 over inverse proportional r squared. So remember, it says the square of the distance r. So we're going to change that then into an equation. So we're swapping the 1 for the k over r squared. Substitute in our values. So 4 was E is equal to k over 50 squared. Rearrange our formula. So we're going to multiply both sides by 50 squared. So 4 times 50 squared is going to equal k. All right. And 50 squared was 2,500. So if we multiply that together, we get k is equal to 10,000. Now we know the value of k, we put that back into our equation. So E is equal to 10,000 over R squared. All right, that's how we've expressed E in terms of R. Now that we have that formula, we can move on to the second part. So calculate the value of E when R is 20. So we know our formula then, E is 10,000 over R squared. So R squared is 20 squared. And if we put that into our calculator, E is 25. Finally, the last one then, we want the value of R when E is 1,600. So I'm just going to do this over here then. So we know R, we want R this time, we know E is 1,600. So 1,600 is equal to 10,000 over R squared. Now again, we need to rearrange this. So we're going to start off by multiplying both sides by R squared. So 1,600 R squared is equal to 10,000. Now we need to get rid of the 1,600, so we're going to divide both sides by 1,600. So R squared is 10,000 divided by 1,600. And remember, we just want R. So to get R, we're going to need to now square root the other side. So square rooting both sides gives us the square root of 10,000 over 1,600, and that means R is 2.5. So be really careful when you've got squareds. If you want to find the single value, remember the inverse of squaring is square rooting. So to get rid of the square, we square root both sides. Remember, it's everything on the other side as well. Okay. Last question then. This one again has got no structure, so remember it doesn't mention inverse proportionality at all in the question. So if 12 men can build a wall in 8 hours, how long will it take 4 men? So although it doesn't mention proportionality, we still need to go through the same process. We should understand that the more people we have, the less time it's going to take. So as the number of men goes up, the number of hours will go down. So again, we can choose our own letters for this one. So I'm going to say that the number of men is proportional to inverse of the number of hours. Okay, so let's turn that into an equation. So the number of men is equal to K over the number of hours it would take us. So we were told there are 12 men. So 12 men equals K over 8 hours. To find K, we're going to multiply both sides by 8. So 12 times 8 equals K. So K is equal to 96. Once I know K, I'm going to put it back in to my original formula. So M is equal to 96 over H. So if I want to know the number of men, I do 96 divided by the number of hours. If I want to know the number of hours, I'm going to need to rearrange the formula. So how long will it take 4 men? So we've got 4 men is equal to 96 divided by H. So again, remember we've got to get rid of the division first. So we multiply both sides by H. So 4H equals 96. Now I can divide both sides by 4. So H is 96 divided by 4. And 96 divided by 4 is 24 hours. So if we have 4 men, it's going to take us 24 hours. And hopefully that makes sense, okay? Because we've got 12 men is 8 hours. So my 4 men is now going to take me 24 hours to do the same job. All right, well, thank you ever so much then. That's the end of this unit. If you need to, make sure you go back and re-watch the videos throughout this unit on multiplicative reasoning.